Hey everyone, so we're just going to continue on with this discussion. We're going to talk a little bit about the quadratic formula some more and do a little bit of practice. Should be a nice, quick, and easy one. So just recall that the quadratic formula is a very one-stop shop type of equation that we could use to pretty much solve any quadratic. As long as it's written in that standard notation, the standard form where it's set equal to 0. And remember the equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, it's important to note that besides this, we could still find the solution using factoring. Of course, factoring only works in some cases, so we're actually going to do a combination of that today. We're going to show, you know, factoring using the AM and the grouping method, and then comparing that to finding it with the quadratic formula. So here's our first quadratic equation. Find the solution set. Do you use factoring and the quadratic formula? You can pause the video, work on stuff, and we'll go over in a second. All right, so when we go to factor it, we're going to do pretty much the same thing for both. We're going to have to rewrite this. Now what I'm going to do is I'm going to add the d squared over and the 2 over to both sides. I like doing this mainly because I like having the term in front of d to be positive. And we end up with d squared plus 3d plus 2 equals 0. All right, now for the factoring method, we have to find two numbers that are going to multiply to 2 and add to 3. Because of the fact that this is a standard form where the leading term is 1, I can go straight to the factoring. So here, the two numbers will end up being positive 2 and positive 3. Positive 1. When we multiply these, we get 2, and when we add them, we get 3. So my numbers are going to be d plus 2 and d plus 1. Setting these each equal to 0, I get d plus 2 equals 0, and I get d plus 1 equals 0. From here, I just solve for d. So for this one, I subtract the 2 over, and I get d equals negative 2. And here I subtract the 1 over and get d equals to negative 1. So my solution set would be written as negative 2, negative 1. Now for the quadratic formula. So again, I'm using this standard form of the quadratic. So it's negative b, which in this case is 3, plus or minus the square root of b squared, which is 3, minus 4 times 1 times 2, all over 2 times 1. So when I simplify this, I get negative 3 plus or minus. Now this ends up being 9 minus 8, so it's going to be square root of 1 over 2. I can clean this up a bit, so it'll be negative 3 plus or minus 1 over 2. So I get minus 3 plus 1, which if I do this, I end up getting negative 1. Or I could do minus 3 minus 1 over 2. Because remember, the plus or minus I have to do it both times. So this will actually get me negative 2. So either way, I get the exact same equation. Of course, showing the work, it's going to take a lot longer sometimes to show the quadratic formula, but you'll always get it right as long as you do the plus or minus. All right, here's the next set. Pause the video, work itself, and we'll go over in a second. All right, same thing here. So I'm going to add the z over to the other side, and I'm going to subtract the 80 to the other side. So my new quadratic will end up being z squared plus 3z minus 180 equals 0. So from here, two numbers that multiply to 180 and are going to add to 3. If I go through all the terms here, the only numbers that pop up will end up being positive 15 and negative 12. they multiply to negative 180, and then when I add them, I get positive 3. So my factors will end up being z minus 12 and z plus 15. Set each one equal to 0, so I get z equals 12 from this one, and I get z equals negative 15 over here. So my solution set would be negative 15 and 12. The quadratic formula, when I go to write it out, it's negative 3 plus or minus the square root of 3 squared minus 4, 1 times negative 180 all over 2 times 1. So to clean this up a bit, I get negative 3 plus or minus. Now 3 squared minus 4 times 1 times negative 180 gives us 729. So the square root of 729 all over 2. If I put this in the calculator, this ends up actually being the square root or the 27. So negative 3 plus or minus 27 all over 2. So from here, I could have negative 3 plus 27 over 2 and negative 3 minus 27 over 2. And when I plug these into the calculator, negative 3 plus 27 is 24 over 2, which is equal to 12. And this one will end up getting me negative 30 over 2, which is negative 15. Again, same exact answers I got up here. This is the third one, and I believe possibly the last one. So pause the video, work itself, and we'll go over in a second. Alright, so because this is not one of those standard ones where the leading term is 1, I'm going to have to take the first term and the last term and multiply them. So 2 times 18 is 36. Now because this number is positive but the middle term is negative, the two numbers I'm looking for have to be negative. The only numbers that work are going to be negative 3 and negative 12. Remember, just start from 1, keep going up until you find two numbers that will add up to that middle term. So remember, the way that we do this is not like the other one. We are going to have to actually do a little bit extra work. So we have 2x squared, and then I'm going to replace the 15x with minus 3x minus 12x plus 18. Group the first two terms, group the last two terms. And what I have here, the only number I could pull out of there is an x, and I'll be left with 2x minus 3. Over here, the only number that I can pull out is going to be a negative 6. So I'm going to be left with 2x minus 3 here. So my complete factoring will be the 2x minus 3 that I share, and the x minus 6 that's remaining. Taking both of these and setting it equal to 0, I get 2x minus 3 equals 0, and I get x equals, x minus 6 equals 0. So doing the math here, I add the 3 over, and I get 2x equals 3. Divide both sides by 2, and I get 3 halves. Over here, I just add the 6 over, and I get x equals 6. So my solution set will be 3 halves and 6. So just double checking with the quadratic, it's negative, now I'm going to use this original one, negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So cleaning this up a bit, I end up getting 15 plus or minus square root of 81 all over 4. Square root of 81, that's a perfect square. So I can replace that with 9. So 15 plus or minus 9 over 4. So my two setups are going to be 15 plus 9 over 4 and 15 minus 9 over 4. Now 15 plus 9 is going to give me 24. So 24 divided by 4 is 6. And 15 minus 9 is going to be 6 divided by 4, which simplifies to 3 halves. So again, we get the original. And there we go. So again, you can choose which one you want to do. Quadratic pretty much always gets you to the answer regardless of the setup. Factoring, you kind of have to work a little bit. If it specifies what type to use, you will have to follow that. We're actually going to go over a few more other ways to get a solution set. And again, you will be asked to do these specifically, but if it doesn't specify, you can choose whichever one you feel more comfortable with. So here are the exit questions. Throw your answers up when the video pauses. Make sure to complete the rest of the notes and submit that in tomorrow. If you have any questions, please let me know. Send me a message on Remind or email or something. Reach out, join Extra Help, and I'll see you later. Have a good day.